Hello everyone, myself Nipun Agarwal, and today I'll be presenting my research project titled Physical Air Security and Massive MIMO, Challenges and Open Research Directions Against Passive Eavesdroppers. So Massive MIMO is a key technology driving the rapid evolution of modern wireless communication, forming a cornerstone for 5G networks and poised to play an even larger role in the upcoming 6G systems. It employs large array of antennas, sometimes in hundreds, at the base station to simultaneously serve multiple users, dramatically increasing the data rates and spectrum efficiency of wireless channels. However, along with this tremendous advantages comes its own unique challenges in securing these communication links. A fundamental security threat in wireless network comes from eavesdroppers, who attempt to intercept transmitted signals without detection. This problem becomes especially daunting when the eavesdroppers are passive, silently listening in without transmitting or revealing their presence. The base station often has little to no knowledge about the channel conditions of these passive eavesdroppers, creating a critical gap in designing effective security solutions. And thus, my project focuses on addressing these challenges, ensuring robust and efficient physical layer security and massive MIMO downlink transmissions when faced with passive eavesdroppers with unknown channel states. The core objectives are to develop a detailed simulation model that realistically represent massive MIMO scenarios under such conditions, to analyze the effectiveness of different secure transmission strategies, and ultimately to provide insight that can drive the design of scalable, energy efficient, and secure wireless communications for future networks. Next, I want to emphasize the importance of ethical considerations embedded in this research. Protecting privacy is a fundamental human right, and in wireless communication, safeguarding confidential user information is paramount. Physical layer security offers a valuable approach that enhances security at a foundation level, complementing traditional cryptographic methods. This is particularly crucial as conventional cryptography faces emerging threats from quantum computing, which might render current encryption vulnerable. At the same time, we must remain mindful of the dual use nature of security technologies. Tools that may provide privacy protection can potentially be misused to evade law monitoring or to facilitate illicit activities. Hence, responsible development, deployment, and regulation of physical air security are essential to ensure they serve the broader good of the society without compromising public safety. Transparency is another critical dimension. It is important to clearly communicate what physical security can and cannot guarantee. Users should be aware that no technical measure is foolproof and that security depends on many factors, including environmental conditions and the system parameters. So, from a research integrity standpoint, rigorous evaluation that accounts for practical uncertainties like imperfect channel knowledge helps avoid overstating security results and supports trustworthiness. Turning now to sustainability, which is becoming increasingly critical for all technology domains, including wireless communications. Massive MIMO systems with the massive antenna arrays inherently demand substantial energies for signal transmission, signal processing, and the maintenance. This energy consumption contributes to the overall environmental footprint of a communication infrastructure. Thus, one of the aims of this work is to investigate how to allocate transmission power wisely between legitimate information and artificial noise injected to confuse eavesdroppers to achieve the best balance of secrecy performance and energy efficiency. This approach helps reduce power wastage and enabling greener wireless networks. By developing security methods that are scalable and robust, we can prolong use the lifespan of wireless hardware and reduce the need for frequent replacement or upgrades. This fosters sustainability by curbing electronic waste and conserving resources. In summary, Securing next generation massive MIMO networks is not solely about defending privacy. It also requires deeply integrating energy awareness and environmental stewardship so that we build wireless ecosystems that are safe, reliable, and sustainable for the long term. To conclude, this research project marries technical innovation with ethical responsibility and sustainability consciousness. Through rigorous simulations and detailed analysis, it explores how physical layer methods perform under realistic and challenging passive eavesdropping scenarios in massive MIMO system. The work highlights the subtle yet crucial balancing act between protecting user privacy, anticipating societal impacts, and upholding environmental goals. This integrated approach will contribute valuable frameworks and insights that can guide the secure design of future wireless networks, ensuring they remain trustworthy, resilient, and sustainable in an increasingly connected world. Thank you.